Okay, here we go. We're going to be leaving the first quadrant, so no more right triangle trig where all the thetas, all your angles were acute, they were less than 90 degrees. Now we're going to do any angle at all, okay? But we're going to start with what we had been doing and expand it. So what we did have was we had an x and y axis, we had an angle theta starting at the standard position. Okay, and this time though I'm going to say I have a point on this terminal side. Okay, so here's my terminal side. I have a point on the terminal side that I'm going to label x comma y. Okay, so xy is a point on terminal side, and don't kind of lose track of that idea. So if I make a triangle here in this first quadrant, then I'm going to have a length for this opposite side would be y, and a length for this adjacent to theta side x. And if I think about it that way, I'll use my old sine theta is opposite over hypotenuse. Well, we need to define the hypotenuse. I'm going to call it r, simply because if I keep rotating this theta all the way around, you know, I will have a circle, and that would be the radius of the circle. So let's call it r. And of course this is going to be found by using Pythagorean theorem. You know r squared is x squared plus y squared. So that will always be coming in handy for us. Looking at cosine theta, the adjacent x over the hypotenuse r, tan theta, the opposite y over the adjacent x. This now becomes our new definitions of the sine, cosine, tangent, and those other threes as well. We're going to use y, x, r instead of the words opposite, adjacent, hypotenuse. So you're going to want to remember this. Okay, just remember x with cosine and y with sine, and that'll be a big help. Alright, well, it's interesting to note that r will never be 0, so the sine and the cosine are always defined. Okay, so there's no angle where r will be 0, but when you look at tangent, the x might be 0, so you'll find that there are places where it is undefined. And that's going to happen when x equals 0. So when does x equal 0? Just looking ahead a little bit, that's when the angle is pi over 2, for example, or 3 pi over 2. Alright, so I want you to go ahead and try and find all 6 of the trig functions given a point on the terminal side, -3, 4. So I'm giving you the x and y. You're going to need to find r first, and then find your 6 trig functions. Go ahead and give it a pause. I'll be right back. Okay, there's my answers. Hopefully you got the same thing as I did. If not, I'll give it. Go ahead. If you did get it, go ahead to the next slide. Otherwise, I'm going to give it a short explanation. All right, looking at sine theta. Sine theta, you know, is y over r. Okay, so the y is 4, and I have to figure out the r. So I said r squared was a -3 squared plus 4 squared. So r squared, it was 9 plus 16. R squared was 25. R is equal to 5. We don't do the plus or minus, we want the positive. So r is 5. So that allowed me to finish my sine, y4 over 5 for the r. And then you can see cosine theta is easily going to be the x value, -3, over that same r value, 5. And tangent, the y over the x. And of course, you can get the cosecant because that's 1 over the sine, okay? So all you have to do is flip these two numbers around, and you have a cosecant given a sine. And then the secant theta, of course, is just a reciprocal of cosine theta. So all you have to do is take a reciprocal of -3 over 5 and get -5 over 3. And of course, cotangent is reciprocal of tangent, so flip those two numbers and you have a cotan. Okay, real quick, we just want to look at the quadrants and what this means for us in general. I got my 4 quadrants, the first quadrant, the second quadrant going counterclockwise, third quadrant, fourth quadrant. And I know in the first quadrant that x is greater than 0. I also know y is greater than 0. And from that you can tell, well, if x is greater than 0, the cosine is x over r. Remember, r is always positive. Okay, so if x is greater than 0, then the cosine of the angle has to be greater than 0 or positive. And the same for y. If y is greater than 0, then I know the sine of the angle is positive. And because tangent is y over x, the tangent, two positives make a positive. So I know all those trig functions, and in fact all 6, will be positive in the first quadrant. Looking at the second quadrant though, I know x is less than 0, and I know y is greater than 0. That leads me to cosine, which goes with x, of theta being negative. Gives me sine of theta being positive because it goes with y, and it gives you tangent of theta, which is y over x, so 1 positive, 1 negative, leaves you with a negative. Okay? So there's that. In the third quadrant we can play the same game. X is less than 0, but y is also less than 0. So here the cosine has to be negative, the sine has to be negative, and the tangent, two negatives make a positive. And then in the fourth quadrant, of course, x is back to being positive, y is still negative, so the cosine is positive, the sine is negative, the tangent, 1 positive, 1 negative, makes a negative. Now, some people like to remember a good way to remember this, a mnemonic given by all students, making sure you go in the same direction as we name our quadrants. Take calculus, and what this is telling you is who's positive in that quadrant. So it's answering the question, who's positive? So they're either all positive in the first quadrant, but in the second quadrant, the sine is positive. In the third quadrant, the tangent is positive. And in the fourth quadrant, the cosine of an angle will be positive. So that's a nice way to remember it. Seriously, it's not too hard to think about x's and y's either. So let me give you an example though. Here's an example. Given that the tangent of theta is minus 5 over 4, okay, but you also know that the cosine of the angle is greater than 0. They want you to find the sine of theta and the secant of theta. So the trick here is to realize that tan theta, we've got to think about the quadrants, is negative. Tangent is negative in the second and fourth quadrant. So this is second or fourth quadrant. The cosine of theta is positive, and that only happens in the first or fourth quadrant. So the only way to make both of these conditions true is to be in the fourth quadrant. So this angle theta must lie in the fourth quadrant. That's an important part. Now, when you're looking at tangent theta, it's given by y over x. You can simply assign. It would certainly work that y is a negative 5, because y is negative in that fourth quadrant, and x could be 4, making sure it's positive, for x positive in the fourth quadrant. So I've assigned the negative 5 to y, the 4 to x, makes my tangent come out right. It also now allows me to find r squared. So I'm going to find r squared. R squared will be x squared plus y squared. R squared is 41, so taking the square root of both sides, I got r is equal to square root of 41, and that doesn't reduce. So we're kind of stuck with that big number. That's okay. But now I want to go ahead and find the sine of theta. Sine of theta is simply y over r. So y, remember we had assigned y the value of minus 5, and r is now square root of 41. I simply need to rationalize this. Sine of theta minus 5 square roots of 41 all over 41. Alright, I'm going to go to the next page and try and see if I can remember how to do the secant theta. Secant theta, I'm going to get there by calling that 1 over cosine theta. So let me find the cosine theta. Cosine theta is x over r. Remember, I had assigned a value of 4 to x, and r was square root of 41. I'm not going to bother rationalizing it because I'm just going to take reciprocal here. So secant of theta is the reciprocal square root of 41 over 4. So now I found both the sine and the secant of that angle. Okay, with this new definition of sine, cosine, tangent, with y over r, x over r, y over x, let's see if we can find values of the trig functions at the quadrant angle, so the straight up and down, the straight across angles like this. I'll start with the first one. I have my x and y axis. If I'm talking about 0 degrees, okay, then I'm right here, okay? I didn't go anywhere, so I'm still, my initial and terminal side are coinciding, and a point on the terminal side could be labeled 1, 0. X is 1, y is 0. I have not left the x-axis. Alright, so this is theta is equal to 0 degrees. I know the r value is pretty easy to figure out in this case. Remember, r squared was x squared plus y squared, so r is equal to 1. Let's find the sine of 0 degrees. You're going to use y over r and get 0 over 1, or just 0. I can do the cosine of 0 degrees is x over r is just 1 over 1 is just 1. Then I could do the tangent of 0 degrees, call that y over x, call that 0 over 1, call it 0. And I've done sine, cosine, tangent for 0 degrees. So I'm going to let you go ahead and try the other ones. I'll get you started. I want you to take an angle, pi over 2 is your angle, so this point right here would be 0, 1. And go ahead and find those same sine, cosine, and tangent. Okay, hopefully you got the sine pi over 2 is equal to 1, the cosine pi over 2 is equal to 0, and the tangent of pi over 2 is simply undefined because you're dividing by 0. Okay, go ahead and see if you can try to find the quadrant angles for pi and 3 pi over 2. Go to the next page when you're ready to see the answer. Alright, there's your answers. Hopefully you got those. If you want a little explanation, listen on. Otherwise, you can go to the next slide. When you're looking at theta equals pi here, then a point on the terminal side, write something here, would be labeled as minus 1, 0. I'm choosing r equal 1. And that sets everything up because this is my x, this is my y value. Sine of pi is y over r, so 0 over 1, 0. Cosine of pi, x over r, x is negative 1, over r is 1, so negative 1 is the cosine pi, and so forth. When you're looking at 3 pi over 2, you want to draw a point on the terminal side and call it 0, negative 1. Okay, x is 0, y is negative 1, r is still equal to 1. Okay, so that sets you up to find all the other trig functions, and it's interesting to note that the tangent 3 pi over 2 is undefined. Okay, I just sort of want to put everything in one place for us. That's kind of neat, get us started. If I put those quadrant angles on here, we had the point 1, 0 at 0 degrees, 0, 1 at 90 degrees, things like that. But what you didn't maybe put together yet was 1, the cosine, I'll remind you, the cosine of 0 degrees is equal to 1, and the sine of 0 degrees is equal to 0. So I could say that the 1, 0 isn't telling me the x and y point anymore. Now it's really telling me the cosine of the angle, comma, the sine of the angle. So x, comma, y is going to be replaced by cosine theta, comma, sine theta. And that makes sense if you remember r is equal to 1, okay? That's why we call this a unit circle. That radius will be 1 unit. And you know, cosine theta was defined as x over r, so now it's just x over 1. Cosine theta is the same as x, okay? So that's what we're getting at on this unit circle. So driving that point home a little bit. If you remember last night's lesson, we were doing those special angles, and we found sines and cosines of all of those, and I'll remind you what those were. We had this 60-degree angle, and cosine square root 3 over 2, sine 1/2. For the 45-degree angle, we had square root 2 over 2, square root 2 over 2 for the cosine and then the sine. And then we had our 30-degree angle, we had the cosine 1/2 and the sine square root 3 over 2. Okay, so that's where we are so far in our unit circle. Okay, before we can finish our unit circle, we'll need to start talking about reference angles. And we're going to find second, third, and fourth quadrant angles can really be thought of as their reference angle which lies in the first quadrant. So a reference angle will always be an angle, let's call it theta prime for reference angle, and theta prime always lies as if it were in the first quadrant, okay? And those are degree marks. I could just as easily have said theta prime lies between 0 and pi over 2. All right, let's define these reference angles as theta prime is the angle between the terminal side and the nearest horizontal. Okay, let me show you what I mean by that. That's kind of a definition. So, if we have a second quadrant angle, so maybe we're somewhere here, and this is my angle theta. This is the terminal side. This was the initial side. So theta prime is going to be between that terminal side and the nearest horizontal, which is here at pi. So right here, this angle theta prime is this much. It's easy to see when you look at a picture like this that in this second quadrant like this, theta prime is simply pi minus theta degree. Or sorry, this is radian, so the reference angle is pi minus theta. If you want to think about it in degrees, you'd have to say 180 degrees minus theta, of course. Now let's go on to the third quadrant. Third quadrant angle might look something like this. All the way to the terminal side is theta. So therefore, to find my theta prime, I go from this terminal side to the nearest horizontal, kind of backwards now, but that's theta prime right there, that amount of angle. So here in the third quadrant, you would find theta prime equal to your angle that you started with minus pi. So just a little bit different than what you had before in second quadrant, because you have to subtract pi to get an angle that lies between 0 and 90. All right, let's look at the fourth quadrant. In the fourth quadrant, an angle might look like this. You go all the way around is your theta. So when you're looking for a reference angle, it would be going from the terminal side to the nearest horizontal right there. So here's your theta prime angle. That's your reference angle. So in the fourth quadrant, find a reference angle by taking 2 pi minus the angle theta. All right, well, obviously we're going to need some examples, so let me go to another page. Let's try an example when you have theta is equal to 315 degrees. Now, I need a reference angle for this. The reference angle needs to lie between 0 and 90. And the only numbers I can play with is either 180 or 360. Okay? So what I'm going to do is I'm going to say theta prime is equal to 360 minus 315, subtracting, getting 45 degrees. So theta prime equal 45 degrees. When you look at it, let me just show you what it looks like. 315 is this angle all the way around, okay? And 45 is the remainder to get all the way around the circle. So this one was 315 and the other was 45. If you looked at the triangle that this angle makes, okay, it's very same triangle that you would have over here at a positive 45 theta prime. So it's got the length of x is the same and the length of y is the same. Okay, the only thing that's different between those two is that in this one the y is positive and in this one the y is negative. Okay, but otherwise they're the same angle. That's what makes them reference angles. Let's do one more example for you to try. I'm going to do it in radians for you. And let's say you had theta is equal to 3. Now, this is a radian measure. It doesn't have a pi. Don't let that bother you. Pi is just a number. You might want to convert it to a decimal in a problem like this. Try it. Right, there's my solution. If you want to hear the explanation, I looked at theta equal 3, and I had to decide, what quadrant that was in. I said it's in the second quadrant because 3 is almost 3.14. Remember, pi is what we normally think of as 180 degrees, that halfway around the circle. So I almost got halfway around the circle, so I'm in the second quadrant. Looking then, theta prime has to be pi minus the angle, so substitute 3.14 for pi minus 3.14 the answer.